0.
Mamma mia, 오늘의 party mamma mia. 오늘이 밤의 시작이야. Mamma mia, 이렇게 불을 밝혀줘. 모두의 party mamma mia. 오늘이 밤의 시작이야. Mamma mia, 이렇게.
Assalamualaikum warahmatullahi wabarakatuh. Assalamualaikum warahmatullahi wabarakatuh. Okay, thank you.
Alright, thank you. So how are you today? Fine. So today we proceed our teaching session. So we will proceed with the heat efficient. So everybody know about the heat efficient? No. What type of method we can use to solve this heat diffusion equation? Who know?
I want to answer. So basically what I know is heat diffusion is categorized under PDE or partial differential equation. So there are several methods to solve heat diffusion. Before that, heat diffusion is an equation that describing the temperature in certain body, but also it can apply in other mathematical problems or like advanced mathematics. So one of the methods to solve this heat diffusion equation is using separation method. Thank you.
So today I want to give you one question about the heat efficient, and we want to solve it by using the separable method. So this is the question.
모두의 party mamma mia. 오늘이 밤의 시작이야. Mamma mia, 이렇게 불을 밝혀줘.
So I want to call three names to solve this question. First, Daniel. Second, IZNI, and third is Lolo.
Okay, from the question 1, du over dt at x equal to 0, we need to find for all t. So we get the u x t equals to capital X and capital T times capital T. Then we differentiate u in terms of t, and we will get x, capital X and capital T prime. After that, we differentiate u in terms of x twice, and we will get capital X, double prime, and capital T. This equation x t prime equals to x double prime t. Then we bring the t at the same place and x at the same place. Then we will get negative lambda square. From the initial condition, so we get the integrating factor t equals to c exponent e to the power of negative lambda t. And possible solution, this is our possible solution, x equal to a cos lambda x plus b sin lambda x. So du over dt at x equal to 0, we get we substitute the value and we will get this answer, exponent e negative lambda square t a cos lambda x plus b lambda sin lambda x. And we make x equal to 0, and we will get e to the power of negative lambda square t A cos lambda x equal to 0. Thank you.
Okay, now I would like to continue the second possible initial condition from my previous friend. Okay, from this possible condition, it stated that u must be equal to 0 for at x is equal to 1 for all t. Okay, you can see clearly here that u, we substitute in the x, which is 1, and also the t, and from this we must equals to 0. Now I would like to explain to you on how to find the lambda. Okay, cos lambda equals to 0, and we can say that which is lambda equals to pi over 2, 3 pi over 2, 5 pi over 2, and so on. And I can say that we can factorize it in a simple ways, and lambda must be equals to n plus 1 over 2 pi, and I can say that n is equals to 0, 1, 2, 3, 4, 5, 6, 7, 8, and so on. Now I will pass to my next format. I will pass my friends IZNI. Thank you.
Now I will continue with initial condition for u equal to a cos pi x cos 1 over 2 pi x. So first we need to differentiate this cos using trigonometric identity. Cos u, cos v, 1 over 2 cos u minus v plus cos u plus v. So after we differentiate this equation, we will get a over 2 cos 1 over 2 pi x plus cos 3 over 2 pi x. Next, we will compare this. From this equation, we will compare it with this equation. So, we got a0 equal to a over 2, and then a1 equal to a over 2 also. After we get this equation, and then we need to substitute lambda into this equation, and then we get this equation. After that, we use summation of n equal to 0, and then after n equal to 0 and n equal to 1, we will get this equation when t equal to 0. After we get a0 and a1, we substitute n equal to 0, n equal to 1 in this equation, and then we will get a over 2 exponential negative 1 over 4 pi squared t cos 1 over 2 pi x when n equal to 0. And then when n equal to 1, we will get e negative 9 over 4 pi squared t cos 3 over 2 pi x when n equal to 1. So this is our solution. That's our solution.
Oh, goes. So the great presentation from our student, to give a big clap to them. So for today, we know how to solve the heat diffusion using the superable method. So I want one person to conclude and give summary about today's lesson.
Me. Yeah. So I want to conclude all of this equation. So this is heat diffusion equation use superable method. It has 6 steps. I have wrote it. First, integrating factor. Next, we apply boundary condition at possible equation. And third, apply condition at x and find lambda. We use lambda to find the repetitive. So fourth, compare equation 1 with initial condition. Fifth, change initial condition. And lastly, we get the answer. So I think that all.
Okay, alright. Thank you to YUZI for the summary. So I think that we have to the end. So we end our class here, and hope you can study more about this and understand how to do this. So thank you for coming today, and Assalamualaikum.
Mamma mia, mamma mia, mamma mia, mamma mia.